that you see between, this is why we have layers of iron and layers of aluminium, because we need the coolant to actually go right inside and cool the entire machine. Okay, and this here, this is called a helium vessel. So we insert all of the magnet into that helium vessel, and all of this is basically filled with liquid helium. Okay? So the way it goes is that the LHC is divided into 8 sectors. Okay? 8 sectors, which things are basically automatic. And we'll come back to this when I talk about quadruples and focus the beam and so on and so on. Okay. All right. So, what's the limitation of the LHC? This is working at 400 megahertz. Megahertz is the radio band. That's why we call this a radio frequency cavity. But the point is the frequency. The problem is the particles go so fast that these magnets, they won't be able to bend them. You won't be able to keep them in a circular trajectory. And this is the limitation. This is what we use to focus the beam. Okay? So we need to do this because when you have a beam of protons into the LHC that goes into a circular orbit, all of the protons don't exactly go at the same speed. So what happens is that some of the particles are bended a little bit more than others. So what happens is that naturally, when you insert a beam of proton into an accelerator like this one, the beam gets wider and wider and wider as you go around. Why is it a problem? The problem of having a wide beam gets into these cables. Okay? So each of these are in red. This is not an alloy. It's coax. So you have a fiber of niobium, which is represents 47% of the cable, and it's coated with titanium because we need something that is mechanically solid to sustain these very big, mechanical forces at play when you power this thing on. Okay, so niobium you can extract from mines. In Australia, in Canada, they have lots of mines. They extract it from the rocks, they melt it. It's okay. We have niobium on the planet. It's not the thing that is the rarest metal. Okay, so we use this to display. This is here to display the way we basically make the junction, or how do we connect two magnets together. Okay. So as I mentioned to you, we have a lot of these flexible parts to adjust for the difference in length when we warm up or when we cool down. This is the heat exchanger, and this is where the cables are basically connected between the two magnets. So what is happening here is that we need the cables to basically get tangled together like this, and we need a mechanical clamp to keep them in place. Then we usually melt these two cables together so we're sure that there is no gap. We cannot afford any gap because when you have 13,000 amps, you can get an electrical arc to this, and this can damage your connection. This is one of the most difficult parts. That's normal that it doesn't work for the first time. But now we learn from what happened. We made extra precaution. We stopped the machine for 2 years between 2013, after the discovery of the Higgs, and 2015, to add even more protection like this bus bar. In case this fails, we can still carry the current into a secondary bar, and then we can stop the machine with much more safety.
เรามาดูข้างในหน่อยนะครับว่ามันเป็นยังไงนะครับอันนี้คือข้างในของเครื่องเล่นนะครับที่ครบสมบูรณ์นะครับนี่คือบีมไลน์นะครับที่ในตอนจะขึ้นลงมาแล้วก็จะมีฝั่งหนึ่งนะครับก็จะมี2เส้นส่วนนี้ก็ไม่มั่นใจว่าน่าจะเป็นหัววัดนะครับ
many particles will be so F is 3. But in reality, the one we need. This is where the beam starts. And here we basically get our protons from hydrogen gas. Okay? So we heat up hydrogen gas, we separate, the atoms. Okay, it's too cold? Yeah? Yeah, sorry, they made it very cold because these days it's... Yeah, but now that the door was open, it's a bit better, no? So we heat up the gas, we separate the atoms of hydrogen.